Okay, class. We continue. So this is the last slide I have presented before, and we now move with our next topic. So we now proceed to chapter 3 concerning random variables and probability distributions. So description of this of this topic. This module deals with random variables, discrete probability distributions, and continuous probability distributions. Now, all right. So, excuse me. So for chapter 2, now I have already introduced probability and probability rules. So you have already an idea on how to solve the probability of a certain event, no? Given certain conditions. So we now proceed to chapter 3, no? Concerning random variables and probability distributions. It has a connection with chapter 2, no? So we now proceed. So the objectives of this chapter or this module, no, so is for you students to solve some problems related to discrete probability distributions, no, and also solve some problems related to continuous probability distributions, no, and then identify the random variable in a probability distribution, no. So we now let's define what is a random variable. When we talk about random variable, it is a function that associates a real number with each element of the sample space. Okay? So it is a function that associates a real number with each element of the sample space. So later I will show you an example to better to appreciate such definition. No? So the random variable is denoted by an uppercase letter. No? So it is denoted by an uppercase letter. Okay? So capital letter. The value of the random variable is denoted by a lowercase letter. So pag random variable, uppercase letter. Pag value ng random variable, we denote it by a lowercase letter. No? So here's the example. In tossing a coin twice, let x be the random variable for the number of heads that turn up in two tosses. Okay? So the possible values x of the random variable x are 0, 1, and 2, considering the sample space. So in here, we toss a coin twice, and x is the random variable for the number of heads that turn up in two tosses. No? So we illustrate that by means of a sample space. So here's the sample space. Okay. And since we have two tosses of a coin, so the possibilities are as follows: head, 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 tail, tail, head, tail, tail. So we have four possibilities. No? And we have x as the random variable for the number of heads. So we consider the first outcome. The first outcome is in the first toss, head. In the second toss, head again. No? So in here, since the random variable, we let that as x, no? Related to the number of heads that turn up. So in here, we have two heads that turn up. Therefore, this random variable x has a certain value in this outcome. In the first outcome, head and head, no? We have x now is equals to 2. no? Because we have here the possible values x. So, marami yan. Okay, so in this example, we have 4. 1, 2, 3, 4. So, this is for the first outcome. In tossing a coin twice, we have 2 heads. Therefore, x is equals to 2. Now, take note, lowercase letter x. Now, if we consider the value of the random variable. In the second outcome, head and tail. In the first toss, head. In the second toss, in the first toss is head. In the second toss, it is tail. We have one head that turns up. No? Therefore, the value of the random variable is 1 because the random variable concerns about the number of heads that turn up. So in here, in 2 tosses of a coin, one head turns up. Okay? Now, we consider the third outcome. In the first toss, tail turns up. In the second toss, head turns up. So in this case, the random variable value is now 1. It is the same as the second outcome. In the last outcome, we have tail in the first toss, tail in the second toss. No head appears or no head turns up. Therefore, x is 0. There. That's why the statement here, the possible values x of the random variable x are 0, 1, and 2, considering the sample space. So we have 0, we have 1, and we have 2. So these are the possible values of the random variable. Now, we have 0, 1, and 2. Okay? Now, let us go back to the definition of the random variable. So, random variable, it is a function that associates a real number with each element of the sample space. So, when we talk about random variable, it is a function. What does that mean if it is a function? It means that it has one possible value only for every outcome. No? For every outcome, for every possible outcome, there's only a single possible value of the random variable. So in this example, in our sample space, in every outcome, there is a single value of the random variable. In the first outcome, we have only 2. In the second, we have 1. In the third, we have 1. In the fourth, we have 0. No? So that is the interpretation of that. No? So that's why it is called function. No? So random variable, it is a function associating a real number, okay, with each element of the sample space. So in this example, this is our sample space, and each outcome in the sample space is what we call element, no? So we call each outcome as element, okay? So associating a real number with each element. So in the first element, or in the first outcome, head and head, no, we associate the real number to the outcome, and we associate it to be equal to 2 because the random variable is concerns with the number of heads that turn up into tosses of a coin. No? Okay? So in the second element, we have head and tail. We will associate a real number to this element, and the association is x is equals to 1. So we have 1. Okay? So 1 as the value of the random variable, no? And which is a real number associated with the second element, no? In the sample space. So that's it. So we can now proceed. Now we have here, if a sample space contains a finite number of possibilities or elements, or an unending sequence of possibilities or elements with as many elements as there are whole numbers, it is called a discrete sample space. Okay? So in this case, to better understand this statement, no? Here's the example. So, as stated, if a sample space contains a finite number of possibilities, when we talk about finite number of possibilities, so meaning we can countable, no? The outcomes of the sample space are countable, no? So there is an ending, no? So we can count in this example, we have 1, 2, 3, 4. It ends with 4. So that is a finite number, right? So we have 4 possible outcomes, okay? Or an unending sequence of possibilities or elements, no? Unending sequence of possibilities or elements with as many elements as there are whole numbers. So here's the example to that. For instance, you will only stop tossing a coin if you get tail, no? So you will only stop, no, in tossing a coin if tail turns up. Okay? So here are the possibilities. So in the first toss, tail. That's a possibility. Another possibility, in the first toss, head, followed by, in the second toss, tail. For the third outcome, first toss, head, second toss, head again. In the third toss, tail, stop. Fourth outcome, head, head, head. Fourth toss, we have tail. Then you stop. Okay? So never ending, no? It's never ending. So there's an unending sequence of possibilities, right? Tail, head, tail, head, tail, head, tail, head, tail, and so forth, no? So there is an unending sequence of possibilities or elements with as many elements as there are whole numbers. So magpapatuloy yan. And Kasing dami ng mga whole numbers, yung bilang ng mga to. Diba? Kasing dami ng mga whole numbers. Okay? So, kasi never ending na yan. Okay? So, pag sinabi nating whole numbers, these are positive integers, right? So, these are positive integers, including 0. Okay? 0 is also a whole number. So, it is called a discrete sample space. No? So, in our first example, we have 4 possible outcomes in the sample space, and this sample space now is called discrete sample space. In the second example, there is an unending sequence of possibilities. Walang katapusan na possibility na kasing dami ng mga whole number. Okay? So if that's the case, tatawagin din natin siyang discrete sample space. Okay? Kasi nasatisfy itong condition para maging discrete sample space siya dahil merong unending sequence of possibilities or elements, unending sequence of elements, unending sequence of possibilities na kasing dami ng mga whole numbers. Therefore, it is called discrete sample space. So, discrete sample space, discrete sample space. Okay? So, we proceed. Excuse me. So, if a sample space contains an infinite number of possibilities or elements equal to the number of points in a line segment, it is called a continuous sample space. So, if a sample space contains an infinite number of possibilities or elements equal to the number of points in a line segment, it is called a continuous sample space. Okay. So, dito class, pag sinabi nating kasing dami ng kada point sa line segment, kung ito yung ating line segment, let's say halimbawa, okay, ito yung 0, okay, or start tayo dito, sabihin natin ito yung 0, ito ay 1, 2, 3, 4, 5, 6, 7. Let's say 0 to 7. Okay? Ngayon, so, walang katapusan yung dami niyan ng mga points niyan sa pagitan ng 0 and 7 dito sa line segment na to. Okay? Bakit? O, tignan natin. From 0 to 1, di ba, meron kang 0.5. Ang dami niyan. Gitna ng 0 at saka 0.5, 0.25. Gitna ng 0 at saka 0.25, 0.125. Okay? So, yung gitna na yan, hindi yan magsasaktong 0, right? Lagi meron niyang value. Kahit maraming 0, okay? Walang katapusan na 0, tapos magkakaroon ng number. Okay? So, ibig sabihin yan, including decimal numbers. No? Including decimal numbers. Diba? So, lahat ng point dito sa line segment na to. So, ibig sabihin yan, kung ito ay x equals 0, ito yung x equals 0.0000000000001. Meron pang marami dyan eh. Marami pang possibility na mas maliit pa sa value na to. No? Okay? So, sabihin, hindi natin mabibilang. Sobrang dami. No? Sobrang dami. Okay? So, pag yung sample space ay nagko-contain ng walang katapusang possibility or elements, na kasing dami na mga points sa line segment, ang tawag natin doon ay continuous sample space. So, ibig sabihin, mas marami pa sa bilang ng mga whole numbers, in short. No? Mas marami pa sa bilang ng mga whole numbers. Okay? So, ito yung example. So, letter A, we have the sample space, no, equal to x such that x is a positive real number, no? So, in this case, positive real number. Pag sinabi nating real number, this includes rational and irrational numbers, no? So, ibig sabihin yan, including decimal numbers, no? Sabihin yan, real numbers, okay, includes integers and decimals. Okay? Decimals. Okay? So, lahat ng excuse me, decimal numbers. Okay? Including integers and decimal numbers. Kaya meron kang rational and irrational. Okay? So, alam niyo naman yung topic na to, di ba? Kailan natin masasabi na yung number ay rational? If it can be expressed as a quotient of, or should I say, if it can be expressed as a ratio of two integers. No? Pag yung isang number, hindi siya ma-express as a ratio of two integers, we call it as irrational. No? Okay. So, this is one example, no? Another example, ito, time naman. May kinalaman sa time. S is equals to T, where T is an element of R. Yung R na to ay set of real numbers, no? Set of real numbers. Such that T is between 0 and 8 hours. O, between 0 and 8 hours. Diba, includes decimal numbers, right? Includes decimal numbers. So, should I say including decimal numbers? Okay? Pwedeng meron kang 1.52 hour o 2.7534 hours and so forth and so on. Okay? So, sobrang dami na kasing dami ng mga points sa isang line segment. No? Okay. So, we can proceed. No? So, ang tawag natin doon ay continuous sample space. Okay? So, these are the examples. No? Itong first, tsaka itong second. Okay? Kasi yung kanilang mga outcomes ay kasing dami ng mga points na nasa line segment. Okay? So, we can proceed. So, a random variable is discrete if its set of possible outcomes or on values is countable. Okay? Ulitin ko, a random variable is discrete if its set of possible outcomes on values is countable. Okay. So, masasabi natin na ang random variable ay discrete. Di ba kanina, pinag-aralan natin yung discrete sample space and continuous sample space. Ngayon, pagdating sa random variable, may classification din yan whether ang random variable ay discrete or continuous. Okay? Kailan natin masasabi na ang isang random variable ay discrete? kapag yung set of possible outcomes niya ay nabibilang. Okay? Kung yung set of possible outcomes niya ay nabibilang. So, ibig sabihin nito, so balik tayo dun sa aking previous example. Okay? Okay, so in this case, so dito, sabihin natin, ang ating random variable ay x. Ang ating random variable ay x, ay yung tatawagin nating number of heads that turn up. Okay. Okay. So, ito yung example natin. Kailan natin masasabi raw ano yung mga possible values niya? So, bago natin matukoy kung kailan natin masasabi na discrete random variable. So, yung mga possible values, number of heads that turn up, 0 head, 1 head, and 2 heads, no? So, 0, 1, and 2. So, yun ang mga possible values ng ating random variable x. Okay, 0, 1, and 2. Okay? So, nabibilang ba? Countable? Countable ba yung mga values ng random variable? Yes. Meron siyang 3 possible values. So, dahil countable, masasabi natin na yung random variable x ay isang discrete random variable. Okay? So, ganun siya. So, we can now proceed. So, ganun din dito sa second example, no? Okay, so, yung mga possible values. So, number of heads that turn up, kung yun ang random variable natin. So, 0 head sa unang outcome. Sa pangalawang outcome, 1 head. Pangatlong outcome, 2 heads. And so forth. Okay? So, 0, 1, 2, 3. So, never ending. Nakasing rami ng whole numbers. So, kung bibilangin lahat natin yan, kasing dami ng whole numbers. Still, no? This is classified as discrete. So, masasabi pa rin natin na ang ating random variable x ay discrete, no? So, that's it. So, kung may discrete sample space, may discrete random variable. Okay, so we can proceed. So, when a random variable can take on values on a continuous scale, it is called a continuous random variable. So, pag daw yung random variable ay may mga values on a continuous scale. Okay, kasing dami ng mga points sa line segment, in short. Continuous, walang putol. No? Every point in a line segment, okay, is included. So, it is called a continuous random variable. Okay? So, balik tayo dun sa previous slide. So, this is one example. X is a positive real number. So, ibig sabihin yan, positive real number, no? Sabihin niyan, lahat ng value ng x na mataas sa 0. Diba? So, sabihin, madami yan. 0.001. Diba? 0.002. 0.0001. Ang dami. Okay? 2.25. Okay? Ang daming possibility. Hindi mo naman yan malilista lahat. No? Hindi mo naman malilista lahat yan. Lahat ng possibility. Kaya meron tayong notation na to na pagsulat. Okay? Ito yung builder notation natin. Okay? Ng pagsulat ng set. Okay? Kapag continuous sample space ang pinag-uusapan. So, yung mga possible values ng x, yung ating random variable, okay? Yung kanyang mga possible values ay in a continuous scale, no? So, meaning, kasing dami rin ng mga points sa isang line segment, and we can classify now the random variable as continuous. O, ito naman. Okay? Ang ating time daw ay isang real number between 0 and 8 hours. Okay, so maraming value, yung value ng t na magsasatisfy sa condition na to, including decimal numbers. So, sobrang dami nun. Okay, on a continuous scale yon. Therefore, ang ating random variable t, no, is continuous. Okay, dito ang ating random variable x ay continuous din kasi positive real number. Take note kapag uppercase, random variable. Pagka lowercase, value of the random variable. So dito yung t na lowercase, value yan ng random variable. Pag t na uppercase, random variable. No? Okay. So ito, we're done with this. In most practical problems, values of continuous random variables represent measured data. No? Values of continuous random variables represent measured data. Diba? Diba sa time, minimeasure ang time? Okay? From 0 to 8 hours. So, including decimal numbers. Okay? So, that is continuous random variables. So, itong example na to. So, yung mga values na yon represent measured data. While values of discrete random variables, okay, represent count data. Okay? So, yung mga value ng mga discrete random variables nagre-represent ng count data, di ba? Nabibilang lang na 1, 2, 3, 4, 5. Di ba? Ganun siya. So, count data ang tawag doon. Okay? So, pag count data, walang decimal. Full number yan. Okay? Represent count data. So, sa aking previous example, 0 head, 1 head, 2 heads. Diba? So, iting mga values ng kada random, yung ating random variable. So, 0 head, 1 head, 2 heads. Okay? Count data. No? Ang tawag natin ngayon dyan, count data. So, yung measure data, yun yung mga value ng time mula 0 hour hanggang 8 hours. No? Including decimal numbers yun. Including decimal numbers between 0 and 8 hours. Okay? So, we have now measured data. Yung mga values ng ating random variable t. Okay? Na continuous random variable. So, we're done with that. We now proceed with two types of probability distributions. So, we're done with random variable. We now proceed with probability distributions. And we have two types, discrete and continuous. No? discrete and continuous. Now, pag sinabi nating probability distribution, it has something to do with the random variable, no? It has something to do with the random variable. Okay? So, in the previous example, 0, 1, 0 head, 1 head, 2 heads. So, kumbaga, let's say, ano yung probability na 0, 0 head in 2 tosses of a coin? Ano yung probability na 1 head in 2 tosses of a coin? Ano yung probability na 2 heads? Okay? So, ibig sabihin, meron siyang distribution. Okay? Distributed ang probability. Kasi, pag pinag-add mo yung tatlo, kasi ito lahat yung mga possibility. So, ibig sabihin yan, 100% mangyayari, kaya 1 ang sum lahat ng yan. Okay? In 2 tosses of a coin. So, check natin, no? So, check natin, 0 head, 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 tail, tail, head, tail, tail. So, ano yung probability na 0 ang heads dito sa example? So, sabihin nyo to, dito 0, dito ay 1 head, dito ay, ito pala 2 heads, sorry. 2 heads, 1 head, and 0 head. Okay? Ano yung probability na 0 head? So, ilang possible outcomes yan? Okay? Sample space. Ano yung number of outcomes dun sa x equals 0? Ilan yung total bilang ng outcome, number of outcomes? Number of outcomes in the sample space. Ilan yung bilang dun sa x equals 0? Isa lang, ito lang, tail, tail. Diba? Tail, tail. Kung tail, tail, so sabihin niyan, 1 outcome. For x equals 0, we have only 1 outcome. Out of, ilan lahat ng outcomes? Head, 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 tail, tail, head, tail, tail. 4 outcomes, 1/4. Okay? And then, para naman dito naman, ilan yung outcomes dun sa ating x equals 1? Dalawa. Ito tsaka yun. 2. Out of 4. Dito sa x equals 2. No? So, meron lang tayong isa. No? Number of outcomes per x equals 2. Total number of outcomes in the sample space, 1/4. Isang outcome lang yan. X equals 2. 1 out of 4. Paki-add nga natin. 1/4 plus 2/4 plus 1/4. 1/4 plus 2/4, 3/4 plus 1/4. Edi 4/4, that is 1. There. No? So, yun ang characteristic ng probability distribution. No? So, pag pinag-add lahat natin ng probability, no, dun sa considering yung value ng random variable, okay, so lahat ng probability dun sa value ng random variable, no, in every random variable, so ang sagot ay 1. So, yun ang probability distribution. No? Yun ang probability distribution. So, it concerning random variable. So, probability distribution of a random variable in short. No? probability distribution of a random variable. So, two types of probability distributions. Meron tayong discrete type na probability distribution and continuous type na probability distribution. So, here's, bago tayo magpatuloy dun sa topic on probability distribution, solve muna natin itong problem regarding random variables. So, here's the problem. Two balls are drawn in succession without replacement from an urn containing 4 red balls and 3 black balls. List down the elements of the sample space and possible values of a random variable y, the number of red balls. So, let's analyze. So, meron daw tayong dalawang bola are drawn in succession from an urn. So, meron kang 4 red balls and 3 black balls. Okay? Two balls are drawn in succession, one at a time. Okay? So, two balls drawn in succession without replacement from an urn containing 4 red balls and 3 black balls. So, two balls drawn, one at a time. One at a time. Okay? So, list down the elements of the sample space and possible values of a random variable y. So, ibig sabihin yan, ano muna yung possible outcomes? If we will draw two balls from an urn, no? What are all the possible outcomes? So, ibig sabihin yan, what are all the possible elements of the sample space? No? So, ano lahat ng possible elements ng sample space? Two balls are drawn in succession without replacement from an urn containing 4 red balls and 3 black balls. List down the elements of the sample space. So, sabihin niyan, pwedeng red sa unang bunot, followed by red ulit sa pangalawa. Diba? Or, red sa una, black sa pangalawa. Diba? Kasi tatlong black balls. Or, black sa una, red sa pangalawa. Okay? Or, black sa pangalawa, or should I say, red, black, black, red. So, black sa una, black din sa pangalawang draw. Yun lang. So, yan na yung sample space. Yan na yung sagot natin. So, list down the elements of the sample space. Okay? So, R1, red ball drawn in the first draw. B1, black ball drawn in the first draw. R2, red ball drawn in the second draw. B2, B sub 2, black ball drawn in the second draw. So, ito yon. So, S equals to, ayan, R1, R2, R1, B2, B1, R2, B1, B2. Okay? Such that R1, R2, okay, R1, R2, R1, R2, R1, B2, B1, R2, and B1, B2 are the elements of the sample space S. Okay? So, yun na yung sagot. So, list down the elements of the sample space and possible values of a random variable y. The number of red balls. So, sabihin niyan, what are the possible values of the random variable y? Ano ba yung random variable y natin daw? Number of red balls. Possible values ng random variable. So, tingin tayo sa mga outcomes ng sample space. Yung sa mga elements ng ating sample space. So, sa unang outcome, red 1, red 2. Okay? Ano yung y? Number of red balls. So, meron kang y equals 2 dito. 2 red balls dito. 1 red ball dito. 1 red ball dito. Value ng y, 0 red ball. Okay? Therefore, 0, 1, and 2. Yun ang mga possible values of our random variable. 0, 1, and 2. That's it. No? Yan ang sagot. Okay? So, ito siya. Since y equals to the random variable for the number of red balls drawn in 2 balls drawn in succession, therefore, counting the number of red balls in each element of the sample space would give us y equals 0, 1, y equals 0, 1, and 2. No? Such that 0, 1, and 2 are the possible values of a random variable y. Okay? So that's it. Did you get it? I hope you get it. No? So we now proceed. So let W be a random variable giving the number of heads minus the number of tails in 3 tosses of a coin. List the elements of the sample space S for the 3 tosses of the coin, and to each sample point assign a value W of W. Okay, let's analyze. So we have 3 tosses of a coin. So list down the elements of the sample space. So here are the elements of the sample space. Okay? So 3 tosses of a coin. List down the elements of the sample space S. So head, 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 tail, head, and so forth and so on. Hanggang tail, tail, tail. And then, ano pa dito sinabi niya? And to each sample point, assign a value W of W. So, ang tawag natin dito, okay, ang tawag natin dyan sa every outcome ng ating sample space ay sample point. Okay? Ang tawag natin dyan ay sample point. Ibang katawagan sa element dun sa sample space. No? Or outcome dito sa sample space. Tinatawag din natin itong sample point. So in this example, ilang sample points meron tayo? We have 4, 5, 6, 7, 8. We have 8 sample points. Ang sabi niya dito, and to each sample point, assign a value W of W. So ano yung magiging value W ng ating random variable na W? Okay. So ano ba yung W natin? Giving the number of heads minus the number of tails. So yun ang random variable natin na number of heads minus number of tails. So ibig sabihin, i-apply natin to in every sample point. In every sample point. So in this case, sa case na to, head, head, head. Okay, ano yung ating W value? Number of heads Kasi sabi niya dito, giving the number of heads minus the number of tails. So, number of heads, 3 heads, minus 0 tail. Minus number of tails. So, ibig sabihin niyan, W equals 3. Dito, number of heads, 2, minus number of heads, 1. Ay, number of tails, 1. So, W is 1. Dito, number of heads, 2. Number of tails, 1. 2 minus 1. So, 1. Dito, W, number of heads, 2 minus 1. Okay, minus number of tails. Dito, number of heads, 1 minus number of tails, 2. So, negative 1. Dito, number of heads, 2. 1. Number of tails, 2. So, negative 1. So, dito, number of heads, 1. Number of tails, 2. So, we have negative 1. Dito, number of heads, 0 minus number of tails, 3. So, negative 3. So, ano lahat ng possible values? And list the elements of the sample space and to each sample point, assign a value W of W. So, yun. Inassign lang natin. Sa sample point na head, W is 3. Sa sample point na head, tail, W is 1. And so forth and so on. No? So, lahat ng possible value ay 3, 1, negative 1, and negative 3. No? So, ito yung ating illustration. Okay, ito yung sample point natin. Each element of the sample space. Number of heads, ayan, number of tails, ito. Ang ating W, okay. So, number of heads minus number of tails ay 3. 3 minus 0 is 3, di ba? 2 minus 1 is 1. And so forth and so on. Okay? So, ganun siya. Okay? So, we now proceed. So, yan yung mga sagot natin. List the elements of the sample space as, ito yun. Okay, and then, into each sample point, ito yun. Assign a value W of W. So, ito yun. 3, 1, 1, negative 1, nakaano na yan. In each sample point. Okay? So, okay, number 3. Statisticians use sampling plans to either accept or reject batches or lots of material. Suppose one of these sampling plans involves sampling independently 10 items from a lot of 100 items in which 12 are defective. Let X be the random variable defined as the number of items found defective in the sample of 10. In this case, what are all the possible values of the random variable X? Okay, let's answer. So, ito yung solution sa problem. From a sample of 10 items, no? There can be no defective item, right? There can be 1, 2, or even 10 defective items, no? So, sabihin niya, so yun ang sitwasyon. No? Kasi, ang hinahanap kasi natin ay all possible values of the random variable X. Ano ba yung random variable X natin? Sabi dito, let X be the random variable defined as the number of items found defective in the sample of 10. So, meron ka dito 10 items. as your sample. Ano lahat ng possible values ng ating random variable kung meron kang 10 items dun sa sample? So, sabihin niyan, ang yung sample space ay 10 yung outcome ng sample space. 10 yung sample points. So, every item, yun ang outcome mo. So, sa kada item, item 1, item 2, item 3, hanggang item 10, ano lahat ng possible values ng random variable? So, sabihin niyan, every item pwedeng defective. So, sabihin niyan, pwedeng dun sa 10, walang defective. Pwede dun sa 10, isa lang. Pwede yung sa 10 items, dalawa yung defective. Or even lahat defective. That's a possibility. No? So, dito kasi sabi niya, suppose one of these sampling plans involves sampling independently 10 items from a lot of 100 items. So, 10 kasi yung kinuha niya doon sa 100 items. At napag-alaman na 12 doon sa 100 ay depektibo. Therefore, may possibility na doon sa 10 na kinuha dito sa 100 items ay puro defective. Bakit? Kasi 12 doon sa 100 items ay defective. So therefore, may posibilidad na walang defective na makukuha, isa, dalawa, or lahat. No? So ano ngayon ang ating sagot? What are all the possible values of the random variable x? Thus, all the possible values of the random variable x is given as x is equals to 0, 1, 2, and so forth until we reach 10. Okay? So, yan ang lahat ng possible values ng ating random variable x. So, we can proceed, no? Okay, so we can proceed. Okay, number 4. Let x be the random variable defined by the waiting time in hours between successive speeders spotted by a radar unit. Find all possible values x of the random variable x. So in this example, x is considered a continuous random variable since all possible values x for waiting time in hours are as many as the points in a line segment. No? So let's analyze. Ang x daw natin ay isang random variable defined by the waiting time in hours between successive speeders na spotted by a radar unit. Okay? So, find all possible values x of the random variable x. So, kumbaga, meron kang dalawang sasakyan. Okay? Yung waiting time in hours ay measure. So, sabihin natin na meron kang ito yung stop point. Okay? Tapos meron sasakyan dito. No, let's say car 1 and car 2. Okay, car 1, car 2. Okay. So sabihin natin na halimbawa lang to, dito yung stop point. Okay, stop point. Okay. Yan ang stop point. Okay, sabihin natin na may nag-investigate o may police. Okay? Halimbawa lang, no? Tapos meron pa parating na car. Okay? So sabihin niyan, ito yung car 1 and car 2. Okay? So, mag-stop muna dito, tapos interview, tapos ipaparating, tapos aalis, tapos pupunta na naman dito yung sa stop point, yung car number 2. Okay? O gaano karaming time yon. So, yung waiting time, no? So, between successive speeders spotted by a radar unit, no? Okay? Gaano karaming time yan? Okay, okay. Tapos car 2, car 3 naman. Gaano karaming time? Yung ang hihintayin. Okay? So, ibig sabihin yung waiting time, ano siya? Continuous. No? Kasi hindi naman mo matutukoy yung exact. No? Yung exact. Kasi decimal point yan eh. No? Pati decimal point kasama dyan. Okay? So, find all possible values x of the random variable x. So, in this example, x is considered a continuous random variable, no? Since all possible values x for the waiting time in hours are as many as the points in a line segment. Diba? Hindi mo naman lahat kasama doon, no? Kasi time siya eh. Okay? So, taas, ano yung ating hinahanap? All possible values x of the random variable x. Ano yung magiging sagot natin? Kung ang ating random variable x ay continuous random variable. So, builder notation ng ating set. No? So, ito yung sagot natin. The random variable x is equals to the set of all values x such that x is greater than or equal to 0. Kasi waiting time in hours. So, yung waiting time na yon, pwedeng 0 hour or greater than 0 hour. Okay? Basta waiting time in hours. And includes decimal numbers. No? It includes decimal numbers. So, yun ang sagot. Okay? So, number 5. Determine whether the following are discrete or continuous random variable. A pair of dice is rolled and x is a random variable that represents the sum of the spots on the two dice. Is this discrete or continuous? A pair of dice is rolled and x is a random variable that represents the sum of the spots on the two dice. Is this discrete random variable or continuous? Okay, analyze natin. Random variable that represents sum of the spots on the two dice. Let's say, dalawang die, no? So, meron kang dalawang dice. 1, 2, 3. 1, 2, 3. So, ano yung possibility? Let's say, lumitaw ay 1. Lumitaw ay 1. 1 plus 1 ay 2. Diba? So, sum of the two spots on the two dice. Let's say, dito, lumitaw ay 6. Doon ay 5. Okay? Or, okay, so 11, ganun, no? So, ano lahat ng possibility? No? 5, 1, 6. Or, no? 6 plus 5, 11. Okay? So, yun ang ating random variable, no? So, maraming value yung ating random variable. Pwedeng 2, pwedeng 11, and so forth. Mabibilang ba? Mabibilang ba lahat? Countable ba? The answer is yes, countable. Diba? Countable yan. So kung countable, discrete random variable. Okay? So discrete random variable. Okay? So mabibilang kasi yan eh. Sum of the spots on the two dice. Let's say 1 and 1. 2 yon, 1 and 2. 3 yung sum, no? 1 and 3, 4 ang sum. Mabibilang lahat yan. Countable. Lahat ng values. Therefore, discrete random variable. Okay, letter B. An economist is interested in the random variable C, the number of persons filing for employment at the labor office. So, discrete random variable, bakit? The number of persons filing for employment. Take note, number of persons. Pag sinabing number of persons, meron bang decimal point na ginagamit pag number of persons? Sasabihin mo ba 2.5 persons? Hindi, di ba? So, number of persons filing for employment at the labor office, pwedeng 1, pwedeng 2, pwedeng 3, pwedeng wala. Okay, countable. If it is countable, it is classified as discrete random variable, no? Kasi mabibilang lahat ng possibility doon. Okay, number of persons filing for employment at the labor office, kasing dami ng mga whole numbers, diba? So discrete random variable. Letter C. The proprietor of a hamburger franchise is interested in the volume of Coke sold per day at her franchise. A proprietor of a hamburger franchise. So, paano to? Is interested in the volume of Coke sold per day at their franchise. Okay, ano yung ating random variable dito? Volume of Coke sold per day. Pag ba-volume, whole number ba lagi ito? Hindi. Let's say, halimbawa, 1 liter of Coke. O pwede rin 1.5 liters of Coke. Okay? Or kahit na sinabi 1.5 liter, yung actual na content pwedeng 1.51 liter, 1.49 liters, hindi naman eksaktong 1.5 liter. No? So, therefore, maraming possibility dahil volume. Okay? So, masasabi natin lahat ng points sa isang line segment ay kasama. No? So, kasi pag volume including decimal numbers, therefore, continuous random variable. No? Continuous random variable. Letter D. A businessman is interested in the random variable Q, the total overtime accumulated by his employees each week. Total overtime, including decimal numbers. Okay? So therefore, continuous random variable. No? So continuous random variable. Letter E. An experiment consists of observing the random variable L, where L is the length of time that it takes for a BA student to finish the major examination. Time na naman, therefore, continuous random variable. Okay, so that's it. Okay, so we proceed. Alright, so this is our next topic to be discussed next meeting. Okay, discrete probability distributions. Okay, that's all for today. Good day, everyone.